Hello everyone, I am Karan, a PhD student in Professor Bhushan Dole's lab at the Department of Chemical Engineering, Indian Institute of Science, Bangalore. As you all know, we are working on point of care diagnostics, and the lateral flow immunoassay, or any lateral flow assay for that matter, is a very important and most frequently used point of care diagnostic assay. To make lateral flow assays, we use a lateral flow reagent dispenser to dispense the test and control lines on the nitrocellulose membrane. So these are the various parts of the setup. This is a Claremont automated lateral flow reagent dispenser. We have a syringe pump over here. We also have a DC power supply over here, and I have connected all of these to the main supply. So we have a lateral flow assay backing card over here. We can assemble the nitrocellulose, wicking pad, conjugate pad and sample pad over here. So these stickers can come off. So I am sure you cannot see these lines in the video, so therefore I have drawn these lines through pen to give you an idea. So the top part is for the absorbent pad of the wicking pad. This part in the middle is for the nitrocellulose membrane. This is around 25 millimeters wide. Then the small part over here, around 5 millimeters, is for the conjugate pad, and this part at the bottom is for the sample pad. What you need to know is you can take out these, and this is a sticker. You can paste the nitrocellulose membrane over here. I have done that. So this is how it would look like. So I have just taken out the sticker. I have pasted the nitrocellulose membrane. This blue colored thing is not the membrane, it is just a translucent cover for the membrane. We want to keep our membrane protected from any dust. Once we do that, we will position our assembly of the backing card as well as the nitrocellulose pasted on it in such a manner over the automated lateral flow reagent dispenser. We will use these magnets to ensure that everything is leveled up. Any small undulations in this pad will cause a lot of issues while we are dispensing the lines. So please make sure that the whole backing card is leveled up. This is one way of doing it. Some other people prefer directly keeping the nitrocellulose membrane over here without the backing card at all. That is completely a matter of personal preference. I prefer dispensing strips once we have pasted nitrocellulose membrane over the backing card. While we are dispensing antibodies as test and control lines on this nitrocellulose membrane, we need to keep a few settings in mind. In this DC power supply, we can adjust the output voltage. One thing which you should keep in mind is the speed with which this dispensing head moves over the nitrocellulose membrane is directly proportional to the voltage which we set over here. So I have set it at 3 volts right now, and you can have a look at the speed. If I were to increase it to 6 volts, the speed increases considerably. At 9 volts, the speed becomes too fast. So this is a setting which we would want to keep in mind. Now I'll discuss all the settings which you have to do in the syringe pump over here. I'm not sure if you are able to see the screen of the syringe pump, but you have to store your antibodies for this experiment in a syringe. You will have to specify in this syringe pump which syringe exactly you are using. So there is a button over here which says find syringe. You click over there and you get a library of all the syringes for which the settings have been stored in this syringe pump. Right now I'm going to use a BD plastic syringe. So you can just click on BD plastic. This is a 1 ml syringe of 4.78 millimeter dia. So I'll just click on that. So I just selected BD plastic, and then over there in the sub menu I selected 1 ml 4.78 millimeter. I'll press accept or enter. We also have a few Hamilton glass syringes. In that case, you will accordingly select the glass syringe which you are using. Right now, I'll just click accept, enter. Once that is done, you will specify the volume of antibodies which you have stored in this syringe. Right now, I'll keep it to default. There is a button of infusion, which means that the antibody will be flowing from the syringe into the tubing. Now, most importantly, you will have to optimize this parameter of flow rate, which is volumetric flow rate in milliliter per minute. Right now, I have selected it at around 0.3 ml per minute. There is also a button which says delay, which means once I click start over here, it will wait for 5 seconds before it actually starts pushing antibody solution into the tubing. Now coming to the most important setting which you have to make with this lateral flow reagent dispenser is the height of this tubing with respect to the nitrocellulose over here. You have to ensure that this tubing should not touch the nitrocellulose membrane, otherwise it can erode it once it moves. At the same time, it should not be significantly above the nitrocellulose membrane, otherwise you will not get uniform lines and you may even get drops instead of lines on the nitrocellulose membrane. Once I am satisfied with the height which I have set over here, then you can find that there are some screws over here. I will use an Allen key and I will tighten it. Right now I have tightened it. So this is how you adjust the height of the tubing with respect to the nitrocellulose membrane. So now I'm going to fill this reagent. This can be an antibody or any other protein which you want to dispense as the test for the control line on the nitrocellulose membrane. I'm going to fill this reagent in this syringe which I have with me over here. You have to be very careful. This is a sharp syringe while handling this. So I'll just fill this syringe with this solution. I'm not sure if you are able to see that in the camera, but this is something trivial. So I have just filled it up. Now, once you have filled it up, you will see that there are a few bubbles over here. We want to get rid of these bubbles, otherwise they're going to cause issue. So I will just you can just if this is a very expensive antibody, you may not be able to do this, but yes, you can just give it a gentle push so that any bubble which is there comes out. Now I'll put this needle into this tubing. You want to be very gentle when you do that, otherwise you may end up piercing the tubing, which is not something desirable. I will fix this syringe over here in the syringe pump. So I have fixed this tubing over here. Now another thing which you want to keep in mind is that this tubing, with the help of a tape over here, you would want to fix it. Otherwise it can come inside over here and it can mess up while we are moving the dispensing head. Start. Once you have made all these settings in the DC power supply, in the syringe pump, as well as the height adjustment in the lateral flow reagent dispenser, we are now ready to dispense our lines. So there is a start, pause and stop button over here. Once I start, the infusion will start over here. I will wait for some time for the antibody to reach over here, and then I will make it move leftward using this switch which we have over here. So I'll just press start. It will take a delay of 5 seconds for it to start infusing the antibody. It will take some more time for it to come over here, and then I will start it. So I'll just press the start button. We can look that this is the line which we have dispensed. Once we dispense, we will find that at the ends the line will be non-uniform. We will mark that part with a pen, and This basically tells us that when we are going to cut the strips, we are going to discard this little portion at the ends where the line was non-uniform. So once you have dispensed it before the strip dries up, this is something which you would want to do. You would want to mark those points and those ends where the line is non-uniform and ensure that everything in between that is uniform. So this part of the video is just for demonstration purpose. I just want to show you how important this parameter of height with respect to the nitrocellulose membrane is. I have already shown you, once I adjusted the height, we got a perfect line over here. What happens if I keep it just slightly above that? You may not be able to appreciate it in the video, but I have increased the height of this dispensing head. And now when I start dispensing it, you will see that the line is not at all uniform. You will find a lot of spots. So you will get dots like this over here. If you have not adjusted the height properly, so in case while you're dispensing you get dots like these, that means you may want to bring this closer to the membrane. How close? Claremont says it should not touch the membrane, because if it touches the membrane, it will erode the membrane. If it is too far above, you will get dots like these. So it needs to be optimized at a sweet spot wherein you get a perfect line. Once we have completed our dispensing process, we would want to take this antibody which is there in this tubing back into the syringe. To do that, we go back to the home screen over here. Again, I'm not sure if this is visible, but we had selected the infusion mode while we were dispensing the antibodies. I will click on it again and it changes to withdraw, and it shows me the arrow direction which says that the antibodies will flow back into the syringe. I will press withdraw and I'll click start, and we will find that all the antibody which is there in this tubing will go back into the syringe. We will keep on doing this until we find that there is a sufficient air gap in the syringe, which tells us that the tubing is now completely empty. I can see a bubble over here which tells me that this tubing is now empty. So now I can press the stop button over here, and now we will put this antibody solution back into the vial, and we are done with the dispensing process. After this, we will take this strip with the line dispensed and we will keep it at 37 degrees for at least 2 hours to let it dry out. Once that is done, we will paste the wicking pad as well as the conjugate pad and the sample pads, and then use a guillotine cutter to chop off the lateral flow assay strips. Thank you so much.